Hello and welcome. So, have you ever really thought about how someone gets a cochlear implant? You might imagine it's just a hearing test and then boom, surgery. But it's actually a pretty deep and fascinating process. Today, we're going to pull back the curtain on the incredibly detailed evaluation that happens long before anyone even steps into an operating room.
I mean, we've all heard of them, right? But what does it actually take to be a candidate? How does a person and their team of doctors decide that their hearing aids just aren't cutting it anymore and that an implant is the right path forward? Well, that's exactly the journey we're going to break down.
And trust me, this journey doesn't start at the hospital door. It begins way before that, with this absolutely essential first step, the pre-operative evaluation. And let's be clear, this isn't just about ticking some boxes. It's a deep dive, a thorough investigation to make sure that for this one individual, an implant is going to be as successful as it possibly can be.
All right, so what is this whole evaluation trying to figure out? Well, it really all boils down to answering three big questions. First, pretty simply, can an implant help someone just detect more sound? You know, the doorbell, a car horn, the basic sounds of life. Second, and this is so important, can it improve their understanding of speech way beyond what even the best hearing aids can do? And third, which is especially critical for kids, will a cochlear implant give them a better shot at developing strong speech and language skills?
So let's get into section 1. As you'd expect, it all starts with the fundamentals. We're talking about a really comprehensive look into a person's hearing and, crucially, their ability to understand speech.
First things first, the team has to figure out the exact nature of the hearing loss. Now, hearing aids are fantastic amplifiers. They make sound louder. But cochlear implants are designed for a completely different problem, severe to profound sensory neural hearing loss. Think of it this way. The tiny hair cells in the inner ear are like little microphones. In this case, the microphones themselves are damaged, so it doesn't matter how much you crank up the volume. The signal getting to the brain is going to be distorted or maybe not there at all.
And to put a number on it, one of the key benchmarks, particularly for kids, is a hearing loss of 90 decibels or more. So what does that feel like? Well, it means a sound as loud as a lawnmower right next to you might be barely audible, if you can hear it at all. When you get to that point, just making things louder usually isn't the answer anymore.
But I really want to drive this point home. This is not just about being able to hear a sound. The real goal here is understanding speech. There's a world of difference between detecting a noise and actually being able to follow a fast-paced conversation with friends and family.
And this is where the rubber meets the road for adult candidates. A huge indicator for candidacy is scoring less than 60% on sentence recognition tests. Now think about that for a second. This is while wearing their best, most powerfully tuned hearing aids. It means they're missing the meaning of at least 4 out of every 10 sentences. That's a massive communication gap, and it's exactly where an implant could be a total game changer.
All right, section 2. So, the hearing loss is severe enough. What's next? Well, now we have to check the wiring. See, a cochlear implant is going to bypass the damaged parts of the ear and speak directly to the auditory nerve. So the team has to be sure that nerve is healthy and ready to carry all those new signals to the brain. And to do that, they use a test with a pretty long name, but a really simple job. The electrically evoked auditory brainstem response, or EABR. Don't let the name intimidate you. Just think of it like an electrician sending a quick test signal down a wire to make sure there are no breaks in the line.
So how does it actually work? It's pretty cool. A tiny, completely safe electrical pulse is delivered near the cochlea. That little pulse zips right past the damaged hair cells and essentially taps the auditory nerve directly. Then, using sensors, the team can measure the brain's electrical response. If they see that response, bingo! It's confirmation that the pathway to the brain is clear and ready to go. Okay, on to section 3. Hearing loss? Check. Nerve function? Check. Now it's time to actually get a look inside. Using tools like CT scans and MRIs, the surgical team gets a detailed blueprint of the person's unique inner ear anatomy. And the surgeons are like detectives, looking for very specific clues on this blueprint. Is the cochlea, that little snail-shaped part of the ear, fully formed and open? Is the auditory nerve there and fully developed? They also need to know the exact position of the facial nerve to make sure they steer clear of it. And they're looking for any bone growth or ossification that might block the path of the implant. This map is absolutely vital for planning a safe and successful surgery. So let's talk about section 4. Up until now, we've been focused pretty tightly on the ear, but a successful cochlear implant journey, well, it involves the whole person. So this next part of the evaluation zooms out, because success depends on a lot more than just anatomy and test results.
This is truly a team sport. You have surgeons checking to make sure the person is medically fit for surgery. You have psychologists making sure their expectations are realistic, which is a huge factor for success. And you have speech therapists getting a baseline so they can measure all the progress later on. It's a complete 360-degree view of the candidate.
And, here's a surprising fact from the research that I think is really important. While the medical check is necessary, poor general health on its own is rarely a reason to say no to an implant. The main question they're asking is simply this: is the person healthy enough for the surgery and the rehabilitation that comes after? And finally, after all the tests, all the scans, and all the conversations, we get to Section 5, the final decision. This is the moment of truth where the entire team, audiologists, surgeons, psychologists, all come together and put every single piece of the puzzle on the table. So what's the big takeaway from all this? It's that this evaluation is a deep, multifaceted process. It's not just a hunch. It's based on hard evidence from objective tests. The whole point is to predict the best possible outcome and to make sure that the candidate is ready in every single way, audiologically, medically, and psychologically, for the amazing journey ahead. And that brings us to our final thought. This entire detailed process is designed to figure out if a person can get an implant. But the real key, what truly determines if it will be a success? Well, that lies in what comes next. Having the right expectations, a strong support system, and a commitment to the rehabilitation that will literally teach the brain to hear the world in a brand new way.